Hello, today's problem is also concerned with the ladder problem. So here there is some additional facts as well, because in addition to the weight of the ladder, we have a person also standing somewhere on the ladder. So according to this problem, the diagram will be somewhat like this. A ladder is inclined on a certain surface. This time the surface is almost rough. So it's a rough surface, and the ladder is inclined at an angle of 30 degree to the horizontal. So this angle is, let me write it as 30 degrees. So this is the ladder, this is the ladder, and its weight is 400 Newton. So that means the weight will be acting from here, and it is 400 Newton, 400 Newton. And we have a person is standing somewhere at a distance of 1/4 length from the bottom. So that means a person is standing here. So a person is standing somewhere here, and its weight is 800 Newton. This is 1/4. So in order to denote those distances, let me use it like this. So this is length L. So this length will be L by 4 up to here. And from here to here it will be L by 2. So from here to here it will be L by 2. So this is the full length, this is half length, and this is the 1/4 length. According to the question, what it says is, here we have no friction, it is smooth, so that's why what it has is only the reaction force R. So it's the reaction force due to the wall. Reaction force due to the wall. And here we have several forces here. Since there is friction, one of the force is the frictional force. Let me draw it here. One of the force is the frictional force, which acts in this direction, and the other force will be the reaction of the ground, which will be in this direction. So the total of those two will be going here, will be going in this direction, which will be resultant force here. So this is FF, this is a reaction due to the ground, and this is the F resultant. Now we need to find the value of the reaction at the wall, which is RW, and we need to find what is FRES. Let us first remember that here we have reaction due to wall should be equal to is acting to the left. This is acting to the left, and the frictional force is acting to the right. In a similar manner, we have a reaction due to ground. This ground is acting up, and the weights. So several weights here, weights which are one is weight of the ladder and the weight of the person. They are acting down. So and let's write the value of the quantities here. So the weight of the person is 800 Newton, and the weight of the ladder is equal to 400 Newton. And this angle is of course 30 degree. And the distance is L by 4, of course, and this is L by 2. Now the first thing that we have to remember is, since the whole system is in equilibrium, we must have the total force. The total force on the ladder in any direction is 0. So if I consider the force vertical only, so considering vertical forces, we will have vertical forces. We should have F up should be equal to F down. F up should be equal to F down, and the upward force here is only RG. So I must have RG should be equal to F down is 2 of them, so WL and WP. So it should be WL plus WP, and that's equal to WL is 400 Newton, and this is 800 Newton, so that's equal to 1200 Newton. So the reaction due to ground is equal to 1200 Newton, and it will be acting in the upward direction. And considering, so if I considering horizontal forces, I will have, so one force is acting in this direction, which is FF, and the other is in this direction, which is RW. So I must have F right is equal to F left, and this will give me F right is the frictional force and F left is the reaction due to the wall, and we still don't know the value of these forces yet. In order to know their values, what I can do is, so taking moment about any point. So let us consider this point about the lowest point. What we'll have is, so if I consider this point as fulcrum, so we have two forces, this and this, trying to move this body in a clockwise direction. So we have these forces trying to move the body in clockwise direction. So that's why I must have this 800 into this distance, and this distance should be equal to this distance into cos of 30. So this should be equal to this into cos of 30. So it's equal to L by 4 cos 30 degree plus, next is this 400 Newton. So it is 400 into this distance. So this is the distance, because the distance is the perpendicular distance from the fulcrum to the line of action of the force. So this will be equal to this into cos 30. So it's equal to L by 2 cos of 30 degree. So this is the forces which are trying to move the body in a clockwise direction, and the force which is trying to move it in anti-clockwise direction is this RW. So it's equal to RW into, so we have to go for this distance. So this distance or this distance, that's equal to this distance into sine of 30. So that's why it should be equal to L sine of 30 degree. So if I go through the cancellations, so L goes and L goes. Now the calculation will give me, so I have to do some pretty long calculations here. So what I will have is, so RW is equal to, so it is RW into 0.5 is equal to, this is 200, so 200 into 0.866 plus, it is again 200 into 0.866. So the value should be, so this will give RW should be equal to, so let me add all these things here. So it is a 400 into 0.866 equal to this much, and this divided 0.5 should be equal to, it is a 692.8 Newton. So the reaction on the wall is equal to this much. And if it is so, this gives us, the frictional force is also equal to 692.8 Newton, because those two are equal in their values. So they two are equal. And now that resultant force will be, so let me do it somewhere here. So F resultant will be equal to, and F resultant will be equal to, from this triangle I have got this, so it is RG square plus FF square. So that will be equal to RG is equal to, as you have got the value here, it is 1200 square plus this is 692.8 square, and that will be equal to, so it should be equal to square plus 1200 square equal to, and 0.5 equal, so this is equal to 1386 Newton. So this gives us the resultant force as this much. So this is the total force. And in vectors, what we need to do is, we need to find the angle as well. So if I define this angle as alpha, I must have tan of alpha should be equal to this by this, and that will be RG by FF. So that's equal to RG is 1200 Newton, and this FF is equal to 692.8. So therefore alpha will be equal to so what I can do is shift to 10. So I'll have 1200 divided 692.8 equal to, so if I have shift 10 of this, it is equal to 60 degree. So the resultant force will make an angle of 60 degree to the horizontal. So that gives us the complete solution. So this is one solution, this is one of the solutions, and the other is this is one of the solutions here.